Support quiz 2. So it says calculate the amount of interest you'll need at the end of the indicated period. If you've got your calculator, please have it out so that you can be practicing whether you're able to get this stuff or not. So the first problem says you invest $200 in an account that pays simple interest for 2% for 6 years. And the formula that I gave you in class for simple interest is that the amount is equal to the principal times the interest times the number of years plus the principal. So this part kind of calculates our interest and we add back on our principal. I'm not going to write out what all these things mean again just because we've done it so many times, but we can talk about it. Principal is what you put in the bank, right? I is your interest. And you always, on these formulas, you always put interest as a decimal, never put it as a percent. Okay, and N here is the number of years in simple interest, and then we're supposed to add back on our principal. Okay, so this review only has 6 problems, but they are more difficult than the other problems that we just worked, so it might take a little bit longer, but shouldn't be. We should take us probably the rest of the time. But we've got, so on this problem, we say, well, I can calculate this, the amount that, since we're putting money in the bank, we're gaining money. So it says I invest $200, so that's my principal, times the interest. Well, it says interest is 2%, but I said, please don't put a percent, put a, so we need to figure out, well, what is 2 divided by 100, which is going to be 0.02, because you have to put a decimal in, not a percent, and then N is the number of years. They tell us it's 6 years right here, plus our principal, which is 200. Okay, now this is going to give us the total, just so you don't have to learn a million formulas. This is going to give you the total amount that you would have after the 6 years. Okay, so if you type this in the calculator, you should be able to type it in just like that. Instead of the parentheses, you could put times, but if you put the parentheses, you'll still get the right answer. Okay, and I'm getting, when I type that in the calculator, I'm getting $224. Okay, but I'm going to go back, and this A stands for the amount I'm going to have. Like, what do I have after I put it in the bank for 6 years at 2% interest, right? So go back and make sure you're answering the question, because it says calculate the amount of interest you'll have. Okay, so I'm not going to have $224 in interest because I put $200 in the bank to begin with. So I need to do 224 minus 200. And that would give me my answer, that's $24, which you should notice that those are a lot smaller, right, anyway. So you're like, okay, if I just wanted to get the $24, I could have just done this part of the formula. Right? I could just done the part that calculates the interest before I added back the 200 on. But I don't want to give you 5 million formulas that you have to keep up with. So, okay. Use the compound interest formula to determine the accumulated balance after the stated period. Assume that the interest is compounded annually. Okay, so we got compound interest this time. Different than simple interest. Okay. Well, simple interest only calculates the interest once a year. Like, it's just going to take it and do it once a year. Compound interest is calculating it. It's adding on every time. So the best example would be like if I had $200 and I put it in the bank and I'm compounding it monthly, then after the first month, I'm going to get some interest on that. Then it's going to take my new balance that I owe, like I have more money now, and it's going to calculate that on top of that. I think there's some videos on chapter 4B that work a whole lot of these problems where it kind of compares those things. But yeah, it's going to compound on top every month. Then you're going to get another payment on top of the money you already had. So it gives you more money if it's compounded. Okay. I want to make sure I give y'all the exact formula that we've been using in class for the compound interest. So here we go. So the compound interest formula is, let me erase this line. We want to take our principal, which is the amount we put in the bank. We want to multiply that by 1 plus our APR, which is just a fancy way of saying interest rate, over the number of times it happens per year. That's what that little n is, the number of times it happens per year. And then all raised to this power of n times y. N is the number of times it happens per year, and y is the number of years, right? Okay, so we're going to start filling this stuff in. So we know our principal is what we put in to begin with, which is our $1,250. Okay, 1 plus APR is going to be whatever interest rate they told us. So I'm seeing 2.3%. Do you ever put a percent in there? No, you need to do 2.3 divided by 100 to get 0.023. Okay, so my APR is 0.023 after I change it to a decimal. N is the number of times this thing's going to happen per year. So I'm going to have to go back and look in the problem, and it says, use the compound interest formula to determine the accumulated balance after the stated period. Assume that interest is only compounded annually, right? So that's really unusual. So if it's compounded annually, it's going to happen one time a year, right? What if it's compounded monthly? 12 times. What if it's compounded daily? 365. So it's kind of unusual to have compounded interest that's only happening once a year, but we'll put our 1 there. And then that means that this n up here is also 1, because these are the number of times it happens per year, times however many years we have. And it says we're going to do this for 20 years. Okay, we talked a whole lot about, please don't put all that in your calculator at once, and there's actually a video that goes over how to type this in the TI-84 calculator, posted under course content. But I could do this part. I mean, this is 1 plus 0.023 over 1. You should get 1.023 if I do that. And then I've got 1 times 20. Well, I know that's just 20. And your calculator absolutely could handle all this. How do you type that 20, exponent of 20? The little rooftop thing, right? You got to type that little rooftop thing in to get, so 1,250 times 1.023 raised to the 20th power. I would say that once you conquer this formula, the hardest part is trying to get it typed in the calculator so that you're getting what you're supposed to be getting. And so what's on my screen is, after I typed it in, okay, but we know we're talking about money, so we're not going to go past the second decimal place because that wouldn't make sense. And this is smaller than 5, so I don't have to round up. So B. Questions about how we came up with that or anything? Use the compound interest formula for compounding more than once a year to determine the accumulated balance after the stated period. So Here's our information. We're putting $3,000 in, so that's our principal. With an APR of 8%, we know we're not going to use 8%. We're going to have to do 8 divided by 100 to get 0.08, right? With monthly compounded. So in my formula, that means that N, if it's compounding monthly, N is going to be 12 because there's 12 months in a year, right? And we're compounding this for 2 years, so this would be my Y part. Okay, and the formula is, the amount is the principal times 1 plus the APR. This is just the same formula we used above. The reason I'm using that is because it's telling me it's compounding, right? There is one other compounding formula, and that's compounding continuously, which is the PERT formula, but this is just compounding. It doesn't ever use the word continuously, so I'm using this one that we had. Okay. So I've got A is equal to, my principal is $3,000. Then I've got 1 plus my APR, which we changed to a decimal and said that was 0.08 over N. And this happens monthly, so that's 12 times every year, raised to the 12 times, how many years? 2? Okay. So I would figure out what's that middle section right there. Okay, you could type it in all at once if you know how to get the fraction key to work on your calculator, which if you have TI-84, it should be alpha y equals. But I could just type in 1 plus alpha y equals, pull up my fraction bar, 0.08 divided by 12, and just figure out what that part is. Now, it gives me a weird decimal, and that might cause me some rounding errors, but I'm going to type this, let me show you what I would, if this happened to me, I'll show you what I would do. Because that's going to be the tricky part, is y'all figuring out, well, how do I make this work? I'm just writing this number down to kind of explain what's going on. But basically, this 6 goes on forever. Okay? So I can't really write that. I can't type it in my calculator either. But I can do 12 times 2. 12 times 2 would just give me 24, right? I could take care of that part. Okay. Now, I should still have this on my screen, right? So, order of operations say raise it to, you do exponents first. So if you hit rooftop while it's still on your screen, it'll say answer, and it'll pull up that, and then type in your 24, and then times 3,000. And that wouldn't make it where I didn't have to round at all. It would give me the exact answer. Does that make sense? So I kept this on the screen, then did rooftop 24, then times 3,000. And I'm getting 3,518.663, and it keeps going. But I know I'm stopping here because we're talking about money, which is going to be this one, B. So $3,518.66. Are you good? Okay. We've got 3 more to look at. If you need me to slow down, please stop me. Okay, we work these in class a lot, but I understand, like, it might just be now starting to click some. Okay. You want to have $75,000 in a college fund in 15 years. So this is what we want. How much will you have to deposit now in an account with an APR of 6% and monthly compounding? So we are compounding, so that means we're using this same compounding formula. Just writing it down so I can make sure I'm explaining it. Raised to that power. Okay. In this problem, what's the 75,000 mean? It's the amount, right? The amount we want. So this time we don't know the principal. We want $75,000. That's what we want. We don't know our principal. That's what we're trying to figure out. How much do I have to put in the bank in order to get this $75,000 in 15 years? So principal is going to be our left P there, 1 plus our APR. Okay, where's my rate at? Oh, I see 6% over here. Can't put percent in, so I need to do 6 divided by 100 to get 0.06. So my APR is 0.06. N means how many times are they going to compound it? How many times is it compounding a year? And I'm seeing monthly. So since it's compounding monthly, that's going to be a 12. And then NY is the last part, raised to the NY power, and N is 12 again. And we're going to put it in the bank for 15 years. We're going to say, well, how much do I have to do? So this one's kind of different, right? This one's got a little bit of algebra involved. So I'm going to write down my 75,000 equals P. Now I'm going to do the same thing here. I'm going to try to get this down to something that I can at least deal with. So I'm going to type in 1 plus 0.06 divided by 12, and I'm going to type that in as a fraction on my calculator. That gave me 1.005. I can take care of the 12 times 15. 12 times 15 is 180. Anybody have questions about where we're at right now? So I just I got what was inside my parentheses down to something a little bit more manageable, but let me make it where it's better. And then this says 180, raised to the 180 power. Okay, what can I do now? What? We could actually figure out what this number is, raise it to the 180 power. We could do that, which would be correct. To keep you from making mistakes, or to keep you from having to deal with a rounding error, okay, I would not go ahead and calculate this. I would go ahead and say, well, it's P times all this stuff, right? We're taking P and we're multiplying it by all this stuff. So in algebra, the opposite of multiplying is dividing. So I could actually take care of this in one step. And the reason that I'm doing that is to save you from rounding that 1.005 to the 180th power and then getting it making you have the wrong answer in the end because you had to round, because I don't know what that is. It might not make you have to round to something crazy. Yeah, like 1.005 to the 180 is 2.454093562. So if you had to write that instead of this, do you see how that would cause a problem? So that's why I want to do 1.005 to the 180. And what's going to happen, let that soak in for a minute. Okay. What's going to happen is these cancel out because we've got the same thing on the top and the bottom, so that just turns into 1. And then this whole thing is my answer. So my principal is equal to whatever 75,000 divided by 1.005 to the 180th power is. This is what I'm getting on my screen. Okay, so A would be the right answer. So if we want $75,000 in 15 years, under those conditions, we'd have to, and we weren't putting anything else in there, we'd have to have $30,000. And in the class, we talked about our child going to college right after 18 years is kind of the one we worked, another example like this. Okay, questions? Okay. We've only got 7 minutes, so I'm going to speed up just a little bit. But this says to calculate the amount of money you'll have at the end of the indicated period. You invest $4,000 in an account that pays simple interest, 3%, 20 years. Simple interest formula. That's important. So we're not using that compound. We're using the simple interest, which is this one. Okay. So my amount is my principal. I'm putting $4,000 in the bank. The amount of interest they said was 3%. I said, please do not ever put the percent. You need to put the decimal. So you need to divide by 100 and make that 0.03. N in this formula is not the number of times it happens per year, because in simple interest it doesn't compound. So you don't have a number of years. N is just, you don't have a number of times it's going to happen per year because it's simple interest. So N here is just the years. So 20 plus my principal. Okay, and then that, you can type it exactly like that in the calculator. I'm getting $6,400. And I didn't have to round or anything. That one it just came out pretty like that. A lot of times simple interest is going to do that. So questions about that one? Last problem. Use the appropriate compound interest. So already I know I'm compounding, and it doesn't say, if it says compounding continuously, I don't think y'all have a ton of those, but that's that different formula that you would use. But you're going to say A is equal to the principal times 1 plus APR over N. That's the number of times it happens per year, raised to the N times Y. Okay, so we've got $3,000. That's our principal. We're investing it for 17 years. An APR of 2.34%. But we know that we've got to do 2.34 divided by 100, which is equal to 0.0234, and we're compounding it monthly. So that means N is 12. Okay. So our principal of $3,000, and then 1 plus our APR, which we calculated was 0.0234 over N, which this is compounding monthly, which is 12 times a year, times, or raised to the NY, or N times Y, so it happens 12 times a year, and they told us that we're doing this for 17 years. Okay, 12 times 17, I can get rid of that. That's 204. Okay, I can try to get this thing. I'm not too hopeful that it's going to come out pretty, because it's 0.0234 divided by 12, but maybe it will. It actually wasn't that bad. It is 1.00195. Remember, if it was not something that came out nice like that, and it was like a decimal that repeats, you would go ahead and say, raise that to the 204, then multiply it times 3,000, right? So I'm going to say rooftop 204 times 3,000. This is the first one that has forced me to round up, because the 9 is bigger than a 5, and so the answer ends up being $4,463.91. Okay.